Okay. So first step, H naught O sub I equals E sub I. H1 O sub I is not equal to E sub I. Step 2. Daphne, what's my step 2?
You find your, or the degree of freedom, so 2 minus 1 times 2.
I'm sorry.
Wait. 2 minus 1 is 1, then 1 times 2.
2 minus 1 times what? How many rows do I have? Or how many columns do I have? 3 minus 1? Okay. So my degrees of freedom is 2. But what am I finding here? In step 2? Critical value. Great. So my alpha is, I think, 0.05?
Yeah.
So then what's my critical value?
2.385. No, wait, 5.991.
5.991. Great. So then I'm going to draw a picture. Here's 0. Son of a gun. Okay? It's okay. All fine. Thank you. So here is a picture. And 5.991. Great. Step 3. Wrong class. Francois.
Yes.
What's my step 3?
E 1 comma 1 is equal to 32 times 38 over 80, which is equal to 15.2.
Where do we get those?
You get those from the total of the row, and then the total of the column, 1 and 1, and then your total overall.
Right, so your row total times your column total divided by your grand total. Great, and then what was your other one you said?
2 comma 3 is equal to 48 times
E2 comma 3?
8, yeah.
Okay. Is
48 times 16 over 80, which is 9.6.
okay, great. And then what? Sorry, Ryan wanted to volunteer next. Ryan?
Go ahead, Ryan.
Number 3?
And then you find the matrix, it's chi.
Yeah, so you put this into your matrix.
And then chi equals
So you do stat calc
stat calc
or stat.
or stat test, and then go up to chi and then put in the numbers in the matrix, and then calculate it again. I got chi equals 2.385, and I got the
3.25?
of
2.385.
2.385.
So, okay, great. That works. Good. All right, so we're going to stick that into our spot here. 2.385. Good. So then, Michaela, what do we do for step 4? You put, which one did you put?
Wait, don't reject H.
Why?
Because it's close to 0.
Yeah, it's closer to 0. So do not reject H naught. So then step 5. Austin, what did you have for step 5?
I said not enough evidence to support the claim, so there's a difference between favorite
This
score.
or that?
Yeah,
The screen.
I know. My computer just did something weird. It like literally just turned off. So yeah, so
By the way.
got it. I kicked the thing. All right, so not. So I'm sorry. What did you say?
Not enough evidence to support the claim, so there's a difference between the favorite score of males and females.
Great. Not enough evidence to support claim of difference between favorite sport of males and females. Now that's the official statement. You could have gone with the generic, which is just not enough evidence to reject claim that the proportions are the same. Either one would be fine. Okay. Good. So now, what going to like musical whatchamacallits and go back over here. And how do folks feel about this one? Scale of 1 to 10, like totally confused, a little bit confused, totally have it. Okay, so like, give me thumbs, like totally got this, medium got this, totally no idea. Okay, so everyone's at least in that kind of medium-ish kind of phase. Okay, that's good. That's reasonable. We're going to go over this more next class, but I want to jump into ANOVA first. So next class we'll cover this. We'll cover and do a couple more of these. But right now we're going to start with we're going to hop into ANOVA, which is super straightforward. So not enough evidence. It's not. It's a support claim of relationship.
No. There's a difference between big sports and
Sorry, that's the difference. Okay, we won't worry about that. Actually, we'll do this. There we go. Like that. So here's your step 5. And like I said, you could just do the generic one instead if you like. Just reject claim portion. Oh no, that's bad. Oh, we knew that was going to happen, didn't we? Okay. We're going to skip the rest of this and get back to it next class, and we're going to jump into ANOVA. So ANOVA, can you flip it back over to that one? How about Omar? You haven't read for us for a while. Go ahead and read.
When comparing more than two means, the t-test should not be used. This section introduces the method of one-way analysis of variance, which is used to test hypotheses that 3 or more population means are all equal. Because the calculations are very complicated, we emphasize the interpretation of results obtained by using technology. The hardest part of ANOVA will be identifying a problem as ANOVA.
Right, and that's not going to be hard at all. The thing about ANOVA is now we're talking about means again. Remember, chapter 10 was numbers, means, x bars and y bars. 11.1 and 11.2 were frequencies, proportions. Now we're back to means again. So it should say means or averages somewhere in the problem, right? And you have kind of lists of numbers, and we'll talk about that pretty soon. Okay, and just a minute. Maybe I'll show you real quick. So see how this one has labels across the top and labels along the side both, right? So an ANOVA will have numbers just will have labels just across the top or the side, but not both of them. So you folks can see here that there's labels just across the top here, nothing along the side. So it's not a contingency table, it's not a matrix. All right, so there's some requirements. Population should be approximately normal. Samples should be independent one another. You don't worry about the requirements. I'm not going to really push those too far. Okay, here's your first step. H naught, all the means are equal. Mu1 equals mu2 equals mu3 is however many mu's you have. H1, at least one mean differs. At least 1 differs. You can't say that mu1 is not equal to mu2 is not equal to mu3 because it might be that the first two are equal and the third one isn't equal. If there's no difference in the means, then the between group variance will be approximately equal to the within group variance, which means that you do not reject the null hypothesis. However, when the means differ significantly, then the between group variance will be larger than the within group variance. That's when we reject the null hypothesis. So you might say, well, what are those things? Okay, so we're looking at the variance between groups and divide by the variance within groups. So here's an example. You have kindergartners, and they range in height from here to here. So their variance is from here to here. Right? Okay, so they're imagine 12th kindergartners. I gotta show it for the camera. And then we have 4th graders. Their variance is from here to here. Right? So that's the variance. And then we have high school seniors. Their variance is from here to here. So their within group variance is not that much, right? So within group variance might be like that much. But if I do between group variance, between the kindergartners and the seniors, then their variance between them is much higher. So it makes, is everyone following me?
Yeah.
So if they were all the same height, then their between variances would be the same as their within variances. And then we'd have something close to 1. But if their between variances are much bigger than their individual group variances, that's when this F statistic becomes large, and that's when we would reject H0. So that's kind of what we're looking at. I'm going to ask you to compute the F statistic for me once in the exam, and all you have to do is take the between group variance and divide by the within group variance. That's it. I'll give you lots of other things to confuse you, like x bar 1, x bar 2, x bar 3, s1, s2, s3, n1, n2, n3, I'll give you lots of things to throw you off. But all you need to do is, I will never ask you to find the F stat, except for to take the between group variance and divide by the within group variance. Because again, we're testing to see if the variance between the groups is a lot different than the variance just within each group. Right? All right. So this is how we're going to do it. I do not want to give you yet another table. You have enough tables now, especially because this is going to be such a small thing. Instead, we're going to use p-values. How does the p-value work? What's our general guideline for unusual?
5% or less.
5% or less. Anything that's 5% or less would be unusual, and you would reject H0. So we're going to take our p-value, and we're going to compare it to alpha. And again, if alpha is small, if the p-value is small compared to alpha, we're going to reject the null hypothesis. If it's less than or equal to alpha. Oops, why is this? Okay. So to test it, we are going to use the TI-83 calculator, find the p-value from the display, and again, if the p-value is less than or equal to alpha, we're going to reject the null hypothesis. If the p-value is larger than alpha, then we're going to fail to reject the null hypothesis. That's all we're doing. It's super straightforward. Here we go. Oh, right. Quick comment. We can't say which one's bigger, just that one of them's different, not which one's different. All right. So here's an example that you do not write down. Just follow along. So here's 3 groups: low blood level, medium blood level, high blood level. We're testing that the means are equal between these 3 groups, alpha 0.05. So first, my hypotheses. Step 1, H0 is that the first mean equals the second mean equals the third mean, because there's 3 of them. H1 is at least 1 differs. Step 2, alpha is 0.05. Done. That's it. Super easy. Step 3, we're going to put our stuff in the calculator, and it'll give us this answer. And we'll say, oh, look, my F stat is 4.07. My p-value is 0.0195. 0.0195, that's what I care about. So I'm going to say, all right, p-value equals 0.0195. So then for step 4, I'm going to say, well, my p-value, 0.0195, and I need to write alpha with the same number of decimal places. So alpha is 0.05. I need to give it 4 decimal places also so that they match up. That makes my life easier. And then which one's bigger? 500 or 195? Yep, that one's bigger, so it means that the p-value is less than, so it's unusual. Right, am I going to reject H naught or not reject H naught? Reject, because my p-value is less than alpha. Whenever your p-value is equal to or less than alpha, it's unusual, you reject H naught. All right, and then finally, that means that we have sufficient evidence that we rejected H naught, that the 3 samples, that the means differ, basically. All right. So I think we should do one together. We'll do this one together. Let's get a reader. How about Lindsay, have you read yet?
Yeah.
All right, Ryan, read.
Researcher wishes to see if there is a difference in the fuel economy for city driving for 3 different types of automobiles: small automobiles, sedans, and luxury automobiles. He randomly samples 4 small automobiles, 5 sedans, and 3 luxury automobiles. The miles per gallon for each is shown at A equals alpha equals 0.05. Tests that claim that there is no difference among the means. The data are shown.
Great. So everybody write down what my first step is. First step, write it down. What's my first step? Go ahead and stop this and restart it. Okay, what's my first step? H naught. What's my H naught? Yep, there's 3 of them, so mu1 equals mu2 equals mu3. Okay. Nor what do you have for my H1?
That at least one mean is different from the other.
Yeah, at least one mean differs. Good. All right, step 2. What's my step 2? Let's pick, who's on the inside side? Oh, yeah. All right, fine. Isla, go ahead. Easy one. Isla, go ahead. What's my step 2? Yeah, look at the alpha. Alpha equals?
0.05.
Yep, that's it. Good. Step 3. All right, so this is where it gets a little bit harder. We're going to do step 3 together. I need to put this stuff into my calculator, into my lists. So, get your calculator out and on. We're going to go to Stat, Edit, and I'm going to clear out my lists. I have all stuff in there from earlier. Clear, enter, clear, enter, enter. Okay. So you go, remember you go up to L1 itself and then hit clear and enter, and then it'll clear off. So my list 1 is, so what is it? Good. 36?
44.
I got it now. Thank you. Thanks. And then my sedans, 43, 35, 30, 29, and 40. And then my list 3, 29, 25, 24. And then I'm going to double check and make sure that I have it right, because I screw that up and I'm just totally in trouble. That's good. So that's good. Someone has their lists in the list 1, list 2, and list 3? Everybody has it? You all have it? List 1, list 2, list 3? All right, So now we're going to do stat, test, and we're going to arrow up because it's the very bottom one. Stat, test, arrow up, ANOVA. Stat, test, arrow up to ANOVA. And we're going to put in, so I now have everyone look up. See how this blank screen ANOVA, blank? I'm going to put in L1, so second one, comma above the 7. Comma's above the 7. Second L2, comma again above the 7. Second L3. Enter. Bam, there I have it. An F-stat and my p-value. P-value is 0.0375. Again, I'll show you the one more time. Stat, over to tests, arrow up to ANOVA, hit enter. Second L1, comma, above the 7. Second L2, comma, second L3. Enter. Done. There's my p-value. 0.0375. So I'm going to do stat, test, ANOVA of L1, comma L2, comma L3. But then what was list 1, list 2, and list 3? Let's see. Well, this was list 1. This is list 2, and this is list 3. So you're going to show me which one you put into which list, so I know that you did the right thing there. And then you're going to say that my p-value is 0.0375. Great. Okay. So step 4, I don't have a picture. So now in step 4, I have to say why. I have to compare things. So I'm going to compare my p-value, 0.0375. And what was my alpha again? 0.05, but I need to have the same no decimal places. So, yep, that's my alpha. Which one's bigger? Everyone find the bigger one. Remember, the fish is always, we already ate the little guy. That's a really bad fish. Okay, try that again. There we go. You already ate the little guy. It's easy to catch. The bigger one's harder to catch. So that means that alpha is larger, which means that I'm going to reject, yep, H naught. So that means that there is enough evidence.
So for this one, is it claims we get H naught still?
Yeah, no difference. No is always H naught. Enough evidence to reject claim. The means are the same. Good. Sorry, good? Yeah. All right. So any questions about this? How do people feel about it? Like, got it, medium, totally confused? Okay, so next class we're going to go over both these quite a bit and kind of get them locked in. All right, so have a great weekend. I will see you all on Monday.